So pretty cold on the slides, they're pretty new, but we'll try to get through it. The title outside is about doing community wireless networks for Hawaii Homelands, but I think there's more to it than that. The Homelands are one great area where we could do something like this. I haven't done anything yet. Quite a bit of experience with wireless kind of thing. You've got anybody who's from Hawaii is probably also familiar with a company called FireTide, which was born here and did mesh networking, slightly different than what I'm proposing, and then has recently all but shut down. I think they're still alive, but they closed the Hawaii office last year. But I think that's more .com craziness than a problem with the technology. Can you not hear me? I have to eat the mic, apparently. In terms of my low voice is noise, great. Okay, so quickly what we'll cover here, what are community wireless networks? What are the benefits and possibilities? How does it work, and what are the options? The rest of it. Community media. Back in the 1700s and 1600s, we had broadsheets, and sort of self-published books and that kind of thing. And then people would publish, like Poor Richard would publish things, and a lot of people wrote anonymously or under pseudonyms about the issues they cared about, and then the paper would be carried out in the street, and people would buy it and read it. If you knew who published it, you'd go back and talk to them about why their idea was right or wrong. In the 1840s, we got this new invention called the telegraph, which was a real revelation, even though it runs at about 10 baud. I'm a ham radio operator. Even I hate Morse code. Went on in the early 1900s. We got the telephone. Now people could, you didn't have to learn a new way. You didn't have to learn how to run a printing press. You didn't have to own a printing press. You could pick up the phone and call a party of interest and share ideas and discourse. In the 1920s, we got radio. Suddenly now you got you're sort of back to the newspapers on a bigger scale. You got a one-to-many thing. And the early history of radio, before the SEC got involved, was sort of anybody with a technical wherewithal could start a radio station. That's still true. It's just, you got a licensing problem now. And then, post-World War II, you got, television. And we still had, this public access idea, the idea that the public at large should be able to access the medium and talk about what was important to them. And today is sort of all that's history. I mean, we still watch television, but I think it's slowly dying. Radio, broadcast radio, is completely corporate controlled. All but. The newspapers are completely corporate controlled. You'll find small pockets of people being able to speak for themselves, but not very much. But the internet has sort of tipped that. Now people can self-publish again. You have these new phenomena, called weblogs or blogs, and people have been publishing on the web for a long time. It's a very sort of low-cost way of getting your ideas out. In fact, some of the Hawaii sovereignty advocacy groups have done a really good job about getting their ideas out via the web. Sort of leveraging that to get their ideas in the newspaper and that kind of thing. So, what's a community wireless network? And you tend to find these factors in it that are not all required for any one, but they're typically small. It's a few houses to a few blocks. It turns out that scaling this stuff citywide is actually pretty hard. Usually nonprofit in nature. That doesn't really mean they're operated by nonprofit, but they're not a for-profit kind of entity. They're really more about hooking people together. No real corporation behind it again. You do find in some municipalities, especially the smaller ones, that the city has thrown in either the rights to tower space or a little bit of money, or at least endorsed it. You can find hybrid partnerships between non-profit or not-for-profit entities and for-profit entities. People who come and lend their expertise, say, who do the stuff for a job, will lend their expertise to help them build these things. They tend to be locally based, so they're locally focused. It's really about where you are, not building nationwide broadband infrastructure. They usually, although this could change in the future, usually utilize off-the-shelf hardware and are therefore low cost. They sort of ride the commodity curve into commodity pricing on hardware. And so you find a lot of people sort of repurposing hardware that was built for one thing into doing something else. So they'll take an off-the-shelf AP and change the software on it and figure out where people can get to it. Action-oriented, again, the goal is to get it done, not necessarily to, and then see how it's used, not necessarily to just create it to see if it works. And a lot of them have a mission to support local social or economic development, much like HOSEF. And I would say they're still highly experimental. There's no one way that's won out yet. There are technologies we'll talk about in a minute, like Monarch stuff, that Locust World stuff that everybody knows of. And there are a lot of other ways to do it that technically may be superior. Okay, so, the nominal mission is, get IP out to everybody, especially people that don't otherwise have it. There's some R&D in this, especially, development. You have to, a lot of the time, do your own software and find or repurpose the hardware and make it weatherproof and all the rest of it, so that, both in the U.S. and outside of it, people can take advantage of these things. And there are easily 20 or 30 groups doing very, very similar things around the world. They share information, steal the best ideas, and sometimes leverage their own ideas. They then turn around and, like I said, sort of distribute open source and free software and sort of either the hardware specs or the supplier lists and that kind of thing for other people to do this, to take advantage of it. So it's sort of open source applied to communications, if you will. And then, some of the groups go further than just sort of experimenting on a small basis. And for instance, there's a group in Urbana, Illinois, that actually goes out and builds fairly big networks. The biggest community network I know of right now is actually in Berlin. It's 50 or 60 nodes. But it covers a fairly good swath of Berlin proper. This is me not knowing how to run PaperCenter, so it billed wrong. But so what are the social benefits? Why do people want this who aren't technologists, right? Well, every citizen has the opportunity to be a producer, if you will. And we talk a lot in this country about consumers. Everybody is a consumer, and we live in consumer society, but I think that man is both a producer and a consumer, often at the same time. Even in this country where we're sort of educated into being consumers. So people like to create, or at least a number of people like to create, and not everybody can create programs and not everybody can create art, but most people can express their ideas. Some better than others, but So it's really a way of people being able to express themselves and get what they are out to other people. And this can be, music, art, journalism, other writings, poetry, etc. Some other examples, churches, even very, very small churches, can webcast their religious services out to their constituents. The reason I think this is interesting is, potentially you can have churches start to rebroadcast or broadcast in native languages. And the other talk I'm doing has got a lot to do about what happens when you take language out of a culture and what happens to the culture after it. And the language is really the functional pin of the social order of that culture. Once you lose the language, you lose the very idea of what the culture was. Local libraries can also use these things to leverage. I participated in one project in East Austin when I lived there, where we put mesh networking on top of all the schools, and then would let the neighborhoods around these disadvantaged schools build out so that all the students had internet access back to the school. You got to know that Southwestern Bell really hated that. Those were DSL lines that they weren't selling. But at the end of the day, these people, had to find a way onto the internet so they could participate in the same way that people who already had it. And that was literally how we did it. We repurposed a bunch of sub-$100 hardware and got a grant. Free wireless kiosks, even for people who don't have computers, can be placed around an area, a municipality, and provide information to tourists or visitors or even, residents in some cases, those people who can't otherwise afford to get the computational resources, the computers. Scott and I have talked a lot about doing some of the parks here in Honolulu. I think it would be really cool to do the beaches, not so much that you want to take your laptop to the beach, but that, the city workers could still be connected. Tourists could pick up their mail in the parking lot, that kind of thing. But, I don't take my laptop to the beach either. I take my cell phone, but. Benefits for educators, I think, almost anybody who's in or around HOSEF sort of gets this. We do computer installations in schools, computer labs. There's no real reason why we couldn't start to extend that into covering the entire school versus just the lab. One of the things I found when I was, some of my history, I helped start Wayport, who's now 12,000 installations. About half of those are McDonald's. They're all Linux-based. And some of the behavior we started to find is that people would go to a hotel lobby to collaborate, or a hotel bar to collaborate, and then with their computers, we started seeing sort of ad hoc meetings happening in hotel rooms with people bringing their computers because they had no other way to really hook them together. Unless they were, and you were talking about people like accountants at top 5, top 6 accounting firms. They were smart, but they weren't technical enough to wire them together and that kind of thing. So we found a lot of really interesting things happening where people would go to a location to start to collaborate and share information with each other. And even if the wireless was incidental, I believe that's a lot of what you see in the coffee shops. Not necessarily the lone person there checking their email, as a realtor showing their clients something, or 2 or 3 people going to the coffee shop to work together. In fact, one of the Mac companies that's fairly famous, got big quickly, that's only got 3 or 4 employees, only recently got an office. They met at the coffee shop every day. They had broadband, had all the coffee they could buy and drink, and they had a sort of semi-quiet place to work. I think that's, pretty cool. Here's a company that started, and they're paying taxes now, and they're doing a couple $1 million a year in software, which is, pretty profitable. They started without having to deal with a lease. Anybody here know what leases cost in Hawaii? I think they're about, $2.50 to $3 a square, depending on where you go. That's $3 for every square foot a month. That's a lot of money. Students can, publish online blogs and newspapers and that kind of thing. I think there's a lot of room for doing web radio on a sort of student and community level. And I think, HOSEF's done a great thing so far getting these labs in, but I think maybe the next step for HOSEF is to start to help the kids in these things take the next step and actually start using the tools to create something different than looking at a star chart or creating the next PowerPoint presentation. So really this is, sort of bridging the digital divide. It's bringing resources and things that normally would be very high tech into places that otherwise wouldn't be able to afford. Once you have this thing, healthcare workers, you're starting to see a lot of e-medicine now in the world. You can actually send somebody with a little less training out and take notes and deal with all the IT aspects of what healthcare is turning into while they're in service. This may not be as prevalent in this country as it is in some foreign countries, but it's still a big thing. And almost every hospital now is going wireless, just because the healthcare workers, are so mobile that they can't go stop and sit and do data entry. A lot of the hospital machinery is also becoming wireless now. So, a lot of social work involves record keeping. I visited these people at these times, and here are my notes. Typically, social workers do that at the end of the day. They sort of keep handwritten notes during the day, and then they go home at night and do that. They have to bring a lot of files along with them, as you can imagine. I don't always pick up the right stuff to take to work with me. Sometimes I have to go back, and that's a big interruption in your day. If it's all online, then it's all already there. You can do things like remote physical therapy. So you can watch people, doing their therapy and talk to them about how to perform correctly. Nursing homes, again, we don't see a lot of this in this country, but there actually are old age homes in some other countries where people just go to do nothing but slowly die. And they don't really have a lot of stimulation other than talking with each other inside the home. Governments, wireless networks facilitate e-government. I mean, that's a fairly bold statement, but it's true. You could do online voter registration once people bought off on that. You provide directions to polling or voting stations, do bill payment, fee payment, that kind of thing. Public service announcements. Once you actually had the ability to say everybody that needs to be connected is connected, you could, you're talking about, there's a guy here yesterday talking about school closings, snow days in Massachusetts, and about how they were programming their system to call everybody. Well, you could just instant message everybody or email everybody that the school is closed today. Once you can sort of assume that everybody's got a phone in the U.S. today. You can't assume everybody's got broadband. Again, you sort of a lot of information dissemination, child care. Child care is a big thing for low-income families. Finding affordable child care, and you could almost imagine a market for child care where people could bid on getting the facility full. My mother did child care in the home when I was a teenager, and the economics between being 2/3 full and full are everything. 2/3 full is just under breaking even, and full is making a living. And I believe that sort of same thing, economic status, happens sort of across the board. And again, this is sort of small providers, not the big nurseries with 200 kids in them. First responders, the police and fire agencies are starting to do a lot of data on the ground, where they will attach a wireless device to the front of or in every police car and fire truck, and then be able to do command and control stuff while they're on the ground. Once you have these networks in place already, then you don't so much need the mobile base station, if you will. It's already present, and they can do command and control from where they are. And again, you can webcast town meetings, city council sessions, group meetings of other kinds, cultural events, that kind of thing. There are some benefits for business here. Create jobs. Somebody's still going to have to maintain these things. Somebody's going to have to learn how to build them. As they grow ever bigger, you can't have one party sort of maintaining them. You really want to sort of distribute the ability to build and maintain these things around the state or around the nation. So there are lots of little pockets of expertise. You don't have somebody having to drive or fly to a location to get it fixed. So if you can build the local expertise to some level and sort of let people bring themselves up, it's better for everybody. It gets fixed faster. It potentially doesn't break as often because people aren't twiddling things that they shouldn't, that kind of thing. And as the people, as a sort of body of people become more educated about how the network should behave or how the thing should behave, they'll be tuned to how it is behaving and notice the disparities and be able to fix things before they really break. Wireless networks provide, mobile workforces with sort of on-demand information. Now, this is, really sort of more for things like meter reading and parking and enforcement and all the rest of it when you talk about it in terms of municipalities. But there are other mobile workforces, and some people still do door-to-door sales, realtors, that kind of thing. There's a whole bunch of advantage in these things. Back when I was at Wayport, I wrote some patents around this stuff, but it turns out you can do a pretty good job of knowing not necessarily who somebody is, but that same person who was here yesterday is here again today. You may not know who they are. You may not know his name's Wayne, but you can do things like present, couponing opportunities and that kind of thing as well. So you can find that it enhances business. And if you believe in broadband, then this is really just sort of expands the market for broadband. Wireless networks will go only so far in creating this infrastructure, and then we'll talk about it a little later in the thing about how you sort of create the next level. So technologies, real quick, we'll talk about sort of the wired versus wireless and dichotomy in the mesh versus the traditional hub and spoke architectures. So, wired networks, well, we started building wired networks in this country in the 1840s. Now we have updated the technology some since then. Still dealing with 1840s technology, but copper-based loops have been around for a long, long time. They are expensive to deploy. They cost real money to put fiber in the ground and, wire up on telephone poles and stretch it in everybody's house. If you go talk to the big ISPs doing this, they'll talk about the last mile problem. They're quite happy to stretch fiber down through a corridor, but they don't want to have to go visit every house or every apartment. They do have a capacity advantage, though. There will always be more capacity in a wire than in a radio. They do tend to become entrenched, so you have the cable MSOs and the ILECs that own the wires, and they don't want to let anybody else on them. They want you to pay. And I think, you've seen sort of some of the recent announcements where the president of SBC, now AT&T, literally came out and said, we expect people like Google to pay for access to the people on our wires, completely forgetting that the people on the wires wanted to get to Google in the first place. So wireless networks, on the other hand, tend to be cheap. They're non-invasive. They're really quick to put up. You can take them down and put them up somewhere else if you want. They enable mobility. It's pretty hard to drag a wire around the building. So I think everybody here has been online, and there are no wires in this room. There are no Ethernet wires to speak of. Maybe there's one back there. I don't know. And there's sort of this question: can we build a ubiquitous wireless network? And that's, I think, still an open question. In terms of architecture, hub and spoke networks are what most of us are used to. And anybody that's built networks, sort of, you drag the T1 line in, or you drag the Ethernet line in, and Ethernet switches are really just sort of hubs in disguise, specialized hubs. And you tend to sort of build these sort of branch and divide networks. They tend to be centralized. They tend to be centrally run. They're relatively expensive because you have to put all the infrastructure at the center and sort of build it out. With radio especially, they tend to be limited to line of sight. They're built around line of sight principles. So, I have to get my radio signal between here and there. And if there's something in the way, then I have to go from here to there and around it. They tend to be high power, high RF power network. Engineering high power radios is an art form. It's not even science, I think. And you end up with a single point of failure. If everything is going back to a single tower and the equipment on the tower fails, then the entire network has failed. Mesh networks, on the other hand, tend to be decentralized. They're literally built to route around obstacles. If radio A and radio C over there can't see each other, but they can both see radio B, then that's how they work. And they find that path. They'll find the optimized path for that. They're relatively cheap because they don't have to be built complete. They can grow. So they can grow incrementally as each person could literally buy their own piece of it. Now, this is almost like the phone company being, I buy a tenth of my line card and the switch and my phone, and presto, I've got phone service. The phone company doesn't want to operate that way. They want to charge you every month for them having written bonds. And the other thing is, in terms of the RF aspects, the radio aspects, they tend to take advantage of low power. In fact, one of the ways of succeeding with mesh networking is to turn the power down. You go start talking to a lot of community wireless group, they all want to talk about their 200 milliwatt cards and their big antennas. And I've gone to talk to several of them, and you start doing the math for them on the whiteboard, and it's like, well, no, you're creating a problem for yourself because the antennas can see each other. One of the things you learn pretty early about antennas is everybody thinks about transmit power. I can transmit 4 watts legally, so I should. Well, if you put the big antenna on the transmitter and you put the big antenna on the receiver, then it's pretty easy to build a link. But if you've got a third party, party C with an antenna, and they can both see it, then whenever party C transmits, then they're both also hearing it. So the more you turn the power up, the more you turn the ERP up, potentially the worse the interference problem you have is. One of the principles in ham radios, you use no more power than you need to close the loop. And there's now starting to be a lot of art in some of the mesh protocols to turn the power down until you can get all the data through without sort of oversaturating the media, the air. Closed networks, these are, Skywave Broadband, who's a customer of ours, but, I still lump them in there, who go out and say, I'll put all the infrastructure up and you'll pay me. They tend to, buy completely off-the-shelf stuff, customized stuff. They tend to buy, high-power radios and that kind of thing. And then they, well, I spent all this money, so you should pay me to get on. So they fractionize the community. You're right back to those who can pay do and those who can't pay don't. And there's this interesting thing about Wi-Fi where people think, well, I can use it in my home for free, so why should I pay for it anywhere else? Open networks potentially can be much more secure. You can actually deploy security protocols in these things. You can run VPNs over them if you want. The software's free. Some people still pay companies like Sandust about, to supply them $40 for a year for software. But on the whole, most people are using free and open source, and I mean free in both senses of the word there. And again, you get this participatory thing where people become educated on how to build it, and one of my favorite ideas is that the ability to generate new ideas is everywhere. I have yet to run across a pocket of 20 people where there aren't a couple people in it who really want to do new things, who want to think about how to solve the problem differently, how to solve the problem to begin with. And the more, as a society, we can take advantage of that kind of thing, I think the better off we'll be. You shouldn't have to be labeled a bright person and have a CTO title to have to say, I think this is how we should do it. If you distribute the problem and let everybody work on it that wants to, you get sort of this more organic thing going on with it. I think Aaron talked about some yesterday where everybody can afford to make their own mistake, but the non-mistakes will pop to the surface. Where if you have a big well-funded thing and it makes a mistake, then all the money's gone. Right? And all that effort and time is gone. Static networks is sort of point-to-point networks tend to be fragile because if you break one link, the whole thing sort of goes away and the routing protocols aren't well tuned for wireless networks, so you have this big, massive routing convergence problem. Anybody here ever run OSPF at an ISP? Does anybody know what OSPF is? OSPF is built for wired networks. It assumes you will run on wired networks. It assumes it won't have to recompute the routing matrix very often. It's Dijkstra's algorithm, and the more networks you have, sort of the longer it takes to compute the new routing matrix. And you can really play hell with a Cisco router by just unplugging the Ethernet cable a couple times, the T1 cable a couple times a minute. Just take it out, plug it back in twice a minute, and the Cisco router will spend the rest of its life trying to recompute the routing table. A lot of the mesh protocols are oriented to assume that those links will break periodically and run similar algorithms, but they're tuned to recomputing a smaller routing matrix rather than a really big one. A lot of the early mistakes in these community networks were that we'll just run OLSR, or not OSR, OSPF. It didn't scale, it didn't work. Dynamic networks, things that can sort of reconfigure themselves on the fly, tend to be robust. They're scalable because you can plug new equipment in as you go, and it adapts itself onto the network. I heard a great idea yesterday from the guy that was talking about VoIP in Massachusetts about building an asterisk blade that you could just plug into an SME environment and it would find itself and configure itself onto the network. There's a lot of power in that one little idea. Now, some of that's hard, but being able to completely plug and play that stuff, a lot of people don't want to mess with it. I've gotten to the point where I don't want to mess with it anymore unless it's the thing I'm working on. I hate maintaining the mail system for Netgate. It just drives me batty. I mean, it mostly works, but when I have to change it, when I have to tweak it, I pull my hair out, I hate maintaining OS Commerce, even though it's what pays, my salary, if you will. I just don't like having to go out and tweak it anymore. I like working on the software that I want to work on. So I think more and more you'll find, people dedicated to solving that problem so it doesn't fall apart anymore. So go ahead and click through this. Sort of the first level of community wireless networks are sort of low socioeconomic status, SES is socioeconomic status areas. People who don't have much money, who don't have much political power, medium density sort of housing, sort of high to medium density, so you find houses closer together, you find high density housing, sometimes government subsidized, and sort of bringing the theme back in, potentially Homelands areas are a candidate for this. Where you find a few small pockets, but there's not a lot of use yet, and so very sort of spread out networks can take care of the capacity needs. sort of, the second phase, you might find like an immigrant community where you've got a lot more people starting to push into an area. Medium social economic status, so sort of, low income but not no income housing. People actually do go to jobs every day, that kind of thing. You start to see more APs and sort of you get, high power APs, which are red here, and low power APs, which are green or blue, sort of, different levels of power. This is based off a simulation for an area. So you add to the network, and it's self-configures itself as you add to it. And then you get into sort of, the yuppie neighborhoods, and you get something that looks like this. Now, a lot of these people tend to have their own connections and their own broadband, but not everybody. And even then, you'll find that you can build community around community links that you won't find out of a bunch of individual cable or DSL links coming out the back of the house. And if you look at it here, I mean, it's sort of, a few high power APs and a lot more low power APs or mesh nodes, sort of all still strung together. Now, you can only take this so far before 802.11 becomes a liability rather than a benefit. The 802.11 protocol is a great thing, but it doesn't scale well into this kind of density. So my thought, and I actually have a couple papers written up on this. And again, I said earlier, the wires will always have more capacity than the radios. You can put more stuff through a wire than you can through a radio to begin with. The radios will always be more expensive than transceivers on the end of a wire. And you don't have the loss through a wire that you do through the air. So it's possible to actually do fence line networking. There was a group in Utah back in the early 90s that started dropping fiber down their fence line. They literally went out and wired their whole neighborhood with a 10 megabit fiber connection, because that's what you could get back then, Ethernet, into every house in the neighborhood, and then brought in, a T1 line and fed the whole neighborhood. Everybody thought it was great. It grew. Well, so it was pretty quickly going back and putting 100 megabit in everybody's house because the technology had just become available. They were taking 100 meg Ethernet switches, burying them in plastic cases, bringing their own fiber. The one problem you get into here is it's pretty hard to cross the street. In order to get across the street, you have to cross the right-of-way, and you're immediately into tariff territory. But there is a way now. There's these things called RONJAs that are free space optics, which is a fancy word for using light to transmit information through the air, rather than through a piece of fiber. And this RONJA unit is actually freely available technology. The plans, the schematics, the whole 9 yards is out there. Anybody can build one. The supplier lists are up. You can put one together without only sort of medium soldering skills. If you don't have the soldering skills, you can buy pre-populated boards for the actual board part and put the rest of it together yourself. The guy who runs the project doesn't actually believe that anybody should build them commercially. He believes that the minute you start building them commercially, you'll start to cut corners. If you're building them for yourself, for your own project, you can afford to take the time and care to actually align the optics properly and all the rest of it. The minute you get into a commercial production thing, you'll immediately start cutting corners to get production up. So, I mean, there's a whole philosophy you go out and visit the site. But literally, this is a 10 megabit full duplex Ethernet link that crosses space. At 10 megabits, they're about 2.5 miles. Now, 2.5 miles is a long, long way when you're talking about doing community network. There is a 100 megabit unit in progress. It'll do about 1 kilometer, or about 20% of the other figure. 100 megabits, full duplex, no telco charges. Right? So literally what you could graduate these community wireless networks into is, fiber or home PNA 10 or the newer home PNA stuff down the fence line where you've got a good solid 100 megabit plus network in the neighborhood, 10 megabit links between the streets, because I don't believe we'll be able to cross the street anytime soon, or 100 megabit across the street. And you can have, 2,000 houses on the equivalent of an Ethernet switch. And then it becomes very, very viable for those people to really share information and, create their own programming and that kind of thing. all the technology is there to do this. It's just a matter of so, you know, the technology is accessible. It's viable. A lot of people, I can show you sort of example after example of people having done this in other places and being successful with it. They're cheap. I mean, it's less than $100 a node if you do it right. And you can literally bring services out into neighborhoods where they didn't. They're cheaper for end users. Somebody still has to pay for bandwidth. At the end of the day, you got to plug these into something that has bandwidth. A lot of them right now sort of bring in T1 lines or steal somebody's cable modem connection or that kind of thing. A fairly good example of it sitting out in the hall, the convention center wants about $800 to turn on an Ethernet port. And Scott decided that was too expensive, so he asked me if I could do something about it. So there's, stuff out of my lab sitting out in the hall here that's supplying wireless to everybody here and literally sort of borrowing it from somebody across the street. Scott and I had talked to several people down low about, you know, paying them for that, but getting through the trees was going to be a little problematic, and I couldn't get close enough to glasses to. So, you know, and it's been fairly reliable, except when we take it down and put it back up the next morning. Then there was some twiddling to get it realigned. So, you know, like the internet itself, I mean, it's really sort of an extension of the internet principles, if not IP, into areas that didn't have it before. Or, you know, potentially where people weren't sharing, because when you're sitting in your house and you have your own cable modem, you're told that sharing is wrong. Don't share your cable modem, don't share your cable signal, you know, theft. You'll hear a lot of that kind of thing. But you can create your own stuff and share it with your neighbors. Whether that be art or poetry or all the rest of it. It's really hard to have a server on a cable modem connection. They don't tend to like that or even allow it. You can't have your own web server at your house. You have to find one. And this is the kind of thing that tips all that back. You can actually have your own infrastructure if you want it, or build your own infrastructure and share it with other people or sell it to other people, whatever you plan on selling. So that's all I really have. Any questions? I know I didn't get into the technology too much, but. Well, you know, there's a couple things. Roadrunner actually has a business class service. It's a bit more expensive. It's, you know, $199 a month instead of $39 a month for the same speed. But you can share it with people in your organization. And you can, you know, get static IPs on it and all the rest of it. But you can share it is the big thing. It's literally for the people inside your organization. So they know there's going to be a bit more use in the lines. And you're paying for it. But at the end of the day, I have business Time Warner cable at my house for a reason. They sort of can't object to what I'm doing in my condo complex. Now I'm doing it mostly for testing for what I'm doing, but I need active testers. So there are some DSL companies as well that purposely allow you to share the connection. DSL's in a bit of trouble now because the RBox has decided they don't like reselling to other providers. But, I think as there's a market for these kind of things, they will come to fruition. And you know, you always have the opportunity to go out and put T1 lines in the back of these networks too. And those are built to share as well. Does that answer your question? Out 3G in Hawaii? You know, you're talking about things like EVDO or whatever the GSM thing. I don't know. It's being built out in a big way in the mainland right now. I mean, there are a number of places where you can get it, and places where you wouldn't expect it, like Las Vegas, Nevada. But I think Hawaii sort of suffers from this island mentality, especially as viewed from the mainland. I mean, everybody wants to go there to work on it, but nobody wants to go there to investigate whether people would use it. marketing problem. I have no idea what the plans are, if any. It probably would have happened faster with Verizon than Hawaii-Tel, but that's my personal opinion. Yeah, Sprint's got it rolling out. T-Mobile claims to have it rolling out. The maps show that AT&T Singular has it here, but I haven't seen it. So maybe I just spend too much time on the windward side. Well, the interesting thing about EVDO is that you'll get more download than you do upload, although they don't really talk about it due to the nature of how the network's architected. The other thing is that the speeds they talk about are the speeds of the cell divided by the number of users in the cell. So when they talk to you about being able to do 384, that's the capacity off the tower, not the capacity to each individual. The questions about what about the security implications of creating mesh networks? The wireless media will always be accessible. So depending on where you're talking about in the security gamut, in particular, it will always be possible, especially in unlicensed spectrum, to mount a denial of service attack against a wireless network, be it mesh or not. I can turn on a 2.4 emitter and be completely legal and take down your unlicensed network today. I just can. And when I talk to ISPs, they really hate hearing that message. But in terms of being able to view the things going on, being able to sort of listen in, those are very sort of solvable problems. Most people in the community tend to advocate that you protect your own data. You talk IPsec or something back to something that's on the wired side or between two hosts on the wired network. There are some potential gotchas even with IPsec. I happen to think that WPA2 is secure enough for all but the most financial of transactions. It's literally too hard to break to not have real money behind it. The effort to break it. Yeah, but that doesn't necessarily mean that even if you're sitting on a node and being able to look at everything passing through it, that you can view it. Now, you can certainly affect the ability of the traffic to pass on. You could inject other traffic so it looks like something different. But there actually are, security protocols like IPsec that are capable of dealing with even that. If you're really serious about doing security, yeah, you would have to IPsec enable everybody at the endpoints. It really depends on the applications and sort of the feelings of the customers. I think a lot of people don't mess with encryption because it's complex. It's not necessarily hard. It's just you have to think about it more. So it doesn't tend to happen automatically for people. Now, a lot of the AP companies will probably this year release sort of this one-button security stuff where you push the button and there's a little protocol that talks between your client and the AP, and you get this sort of WPA secured session inside your house. Very, very similar things could happen with mesh. I think right now most of the focus has been on making them work without the added debugging complexity of getting a lot of encryption going on the links. But there's literally nothing to prevent it. All the cards now will do AES. So you can certainly encrypt hop by hop, but that doesn't stop somebody from who has access to one of the hops from peering at the traffic between. No, not necessarily. A lot of the mesh routing protocols work at the IP layer, but even then you don't necessarily have to each node be on its own subnet. Instead, you can have groups of nodes be a subnet and have an elected node be able to communicate in and out. And if that node goes silent or loses communication for whatever reason, you re-elect another node to be able to communicate in and out. If none of the nodes can communicate, then you had to you had the problem to begin with. Sure, yeah, you can drive down the neighborhood and see people's windows and printer shares all day long. Yep. At the end of the day, it has to be the responsibility of the end user and consumer. You don't want the responsibility to be anywhere toward the core, so you want to push that as far as possible. Because the core makes a mistake, they expose. The core has diabolical ends. They can purposely expose the network. So you really need to get that all the way out to the endpoints. Now, there's nothing to say that one or more of these groups that are creating software couldn't just chop the ability to serve Windows shares that weren't already encrypted away. Now, security is this very fine line between how you share information and how you preclude others from having access. And there's always a sort of a corporate or entity equation to write there about where you're going to put the line. What's important to keep secret and what's important to share, and where between those two things do we put the line down about what's allowed and what isn't. Yeah, you could have one person who took care of it. I think it's better to have 2 or 3 or 4 or more, because they'll check each other. Not everybody will get every problem. If one person turns evil, then the others can check what's happening, can correct it, as a matter of fact. So it's the same thing you talked about in the open source world, where people won't insert backdoors into the source code because it's too easy to find out. All the effort is for want. Very similar thing, many eyes make for shallow system administration. The growth of the networks, yeah. Beyond the range of the DSL, and the cable and MSOs haven't gone there. Yeah, some of that happens in the mainland, at least. I don't know if any of it happening here. In terms of people creating their own networks or some provider coming in and trying to create it. A lot of the sort of third-party networks, if you will, wireless providers, tend to try to cover rural areas with base stations. Of community of people farming, for instance, could elect to each put up a tower and share the infrastructure there. Quite frankly, a community of farmers probably has the wherewithal and the funding to go out and create their own little fiber network in their community once it becomes important to them. Farmers are an amazingly creative class of people. They work every day and think nothing of it. Well, it's funny. A lot of the fiber in the US, at least, follows rail lines. Where do the rail lines run? They run away from the cities. So you'll find like gas pipelines and rail lines and petroleum pipelines almost always have this sign on them saying "warning, buried fiber." In fact, a guy named Williams in Texas emptied all of his gas pipelines, shut them down. No longer will we transport natural gas. He put fiber in them, and it's Wiltel now, because no backhoe operator. Fiber networks are sort of subject to this phenomenon called backhoe fade, which is that the backhoe operator has dug up the fiber somewhere. And fade is sort of this phenomenon where the light dims, but the light really suddenly goes out. it's a bit of an any joke. But no backhoe operator will go anywhere near a high-pressure natural gas line. It's death for them. You know, they see natural gas pipelines line, they say, no, no, we don't dig here, thanks. You know, you carefully mark where they are, and I'll dig right next to them, but I won't go just digging into the area if I see a natural gas line sign there. So, you know, it was a great thing. He got steel protected jackets for all of his lines, and he had possibly one of the best fiber networks in the early 90s. Well, railroad rights of way tend to have fiber running down the side of them. Well, one way or the other, yeah. They could either go and ask AT&T or, you know, WorldCom or whoever has the fiber there if they wouldn't, you know, sort of splice into it for them. Or lacking that, you know, they could potentially buy, you know, some kind of telecommunication service and redistribute it inside the community. Or, I mean, you know, municipalities can write debt. They can literally write bonds that the market will buy and, you know, pay them back at very low interest rates over a long time. It's the best kind of debt out there. And they can go out and, you know, construct their own thing. Literally, they could drop fiber back down the railroad right away, do it themselves, get to the next town. Right, but they still are a part of the county. And no matter what, you're part of the county in the U.S. The county governments, some county governments have done this. Back in Texas, where I came from, who was it? There's the central, I can't remember the name of them now, but basically they're a big power company in central Texas. They get a bunch of power from the dams in Texas and also get paid for every oil well in their area and that kind of thing. Lower Colorado River Authority, yeah, LCRA. A couple rural towns approached them about putting a fiber network back on their towers. They've got power distribution towers that run all over, out to every town. Well, instead of saying, well, yeah, right away, sure, fine, LCRA went out and put the fiber on the poles themselves, on these towers themselves, these, you know, sort of really big metal towers, and then sold cheap access, cheap IP bits and phone bits to these little towns. Completely changed the face of the map in Texas on what telecommunications looked like, because before you couldn't get high-speed services in these places, and now you could. This is sort of back in the ISDN days, but you couldn't find ISDN out in rural Texas. Texas is one of the problem you mentioned in spades. It's you've got really big towns, but then you've got a whole bunch of really little towns that are 40 miles from the next one. But LCRA changed that in central Texas anyway. And I have to believe there are similar entities. You see government now starting getting into municipal broadband a lot in the U.S. as well, even in the big San Francisco. That kind of thing. Any other questions?